Alright, here I'm going to continue with 15. If you need help with this, you can go back to the other video. I just wanted to show you how I can come up with the same answer algebraically. So let's take x plus 3 is less than 4. X plus 3 is less than negative 4. Okay, because we got to take into consideration if it was positive or negative. So we'd subtract 3 here, so we get x is less than 1. Subtract 3 here, and we get x is greater than negative 7. So we come up with the same answer we did here. X has to be between negative 7 and 1. Alright, for problem 16, we're told to solve it. We got 2x plus 5, absolute value is greater than 13. This is going to be an OR because we have a greater. So greater is going to be OR. So we'll set up with 2x plus 5 is greater than 13. 2x plus 5 is less than negative 13. So we'll subtract 5. Okay, so we get 2x is greater than 8. Divide both sides by 2. X is greater than 4. Subtract 5 here. We get 2x. Come on. 2x is less than negative 18. Divide both sides by 2. X is less than negative 9. Okay, so this is an OR. Now, if we're graphing the answer on a number line, we take negative 9. Okay, it's going to be open again because there's no equal to part, and we would shade everything this way. So it's got to either be less than negative 9 or greater than 4. So open because there's no equal to, and shade this way. And so that would be our answers for this. And you may see it as x less than negative 9 or x greater than 4. So it's not an and, it's an or problem when you start out with greater than. Alright, here we're told to solve by graphing. Now again, what we want to do is we're going to graph a line at 2 and then graph this part, x plus 1. So let's graph x plus 1. So x plus 1, our vertex would be here. And, well, we just got to go through the diagonals. So we'll draw, should be coming straight through them. Okay. And same thing over here, should be coming down through there. Alright, my graph's kind of rough, but you'll get the idea. So here, we'll go at 2. So we'll draw a straight line going across. Alright, now, what we do is when they intersect is our answers, and then we got to figure out if it's above it or below it. Alright, so this part would be x is 2. Okay, and this part, x is negative 3. So for this, we want it to come here. So when x is less than negative 3, so we want x to be less than negative 3, or x to be greater than 2. Okay, so we want all this up here. Okay, so x is either going to be greater than 2 or less than negative 3. Now, we could solve this algebraically just to prove that. First of all, remember it's a greater than, so it's going to be an OR problem. Alright, so let's go x plus 1 is greater than 2, or x plus 1 is less than negative 2. So we'll solve, subtract 1, so we get x is greater than 1, which alright, so I have to fix my graph here, because again, yeah, it should have came up through here. Mislabeled my graph. So it's good to check algebraically. I should have came through here. Okay, and then 2 crosses here, and that's where the 1 comes from. Okay, so I messed up on my graph. So x should be greater than 1. Alright, so x is greater than 1. Subtract 1. So x is less than negative 3. So be careful with the graphs. But on the benchmarks, they're probably going to give you a graph. You don't, it's a multiple choice thing, so you just have to pick the points that are here anyway. But you can always test it by solving algebraically. So x is greater than 1, or x is less than negative 3, which is what we came up with here. Alright, for your question 18, you're given a diagram basically like this. I went ahead and labeled this point. And we're supposed to come up with a piecewise function. So we're going to come up with this first. Okay, and so the way we're going to do this is first we're going to come up with the slope of this and see what that is. Alright, so I'm going to find the slope of this. So I'm going to do that by doing the y2 minus y1. Now, it looks like an absolute value function, and I'm pretty sure it is. But let's double check. So we get 10 minus 3 over 9 minus 2. So again, this is x1, y1, x2, y2. Alright, so when we do this, we get a slope of 1. So that's going to be our first part. So, and we go from 2 to 9. So if x is between 2 and 9, we're going to use this part. Okay, then when it's reflected down, okay, we're going to use this part. It's going to be a negative slope to it. So we're going to use if it's between 9 and 15. Now I didn't put the equals to part there because we're going to go up to 9, and once we get to 9, then we come back down. So we don't actually start coming back down until after 9. Alright, so that's our piecewise function for this one.